Always interesting to try a new node. I've tried to do tutorials. I just think I can't keep my head straight with it. So what I'm going to do is provide the GH files for all of this for anybody who wants to play with it. And here's a beautiful form coming from experimentation with the curve node derivatives, which I've never really used before. And you can see the gorgeous geometry that's created there. So let's just go through and make it. We'll turn off the turntable for a second. We'll take this form because I actually very much like it. I try to stay away from symmetry, but it's pretty sweet. I can't complain. And we'll just put it over in shaded so you can see what's going on. How I make this is we'll walk through it, and the script's available on GitHub at mwickerson if you want it. I'll upload it every 10 I make. I upload. Basically, I am doing what I always do. I'm making a point, and actually, I'm making a point into a helix. And I think anybody worth their weight in a little bit of math should be able to figure this out. It is a range that takes a domain that runs through pi in a varied. I shouldn't even mess with the code because it's tied to this longer script that's been lofted and variable piped. So basically, I've just done 6 rotations of it, 6 pi of the domain from 0 to 6 pi because I like to deal in radians, not in degrees. I take that range, I put it through sine and cosine into the y and z factor, and I make a series of points, and there they are. Let's continue. You interpolate that, you have a helix. There's many ways to come at making a helix in Grasshopper. This is the way I like to make it. If anybody knows me by now, I like the gene pool. This gene pool is generating 100 random numbers scrambled between 0 to 1, which are my parameters for these curves. And that is a lot of data. And I've never used derivatives before, except when I was in math. Certainly never used them in Grasshopper. What it gives you is a point of where those derivatives take place, and it gives you the vectors at each of those points. And if you know anything about Grasshopper, points and vectors are very similar, except you can't see vectors. So here are the vectors. There's our first derivative as velocity. There's our second vector as acceleration. And there is our third vector, which they call jolts. And you can see how huge that gets. So I just want the directions of these vectors to change throughout where I am on this system. So if I grabbed all of them, I have to take this off to see them, ungroup. You can see that we've got a lot of awesome data. And I'm not going to deal with the amplitude of those vectors. I'm going to deal with just the direction of those vectors. So kind of a roundabout way of undervaluing those vectors for the information they're giving. I'm using them as a direction to build lines, lines, and lines and keep them all consistent with the same length. When I do that, I know I can take them and go from one line to the next line and blend those curves together. Start getting some gorgeous geometries just from 2 curves. And the power of NURBS, a non-uniform rational B-splines, are something you want to explore in Grasshopper and in Rhino because it is what makes that program so enticing to me to not go into other programs. So the blending of those 2 curves, the blending of the other curves, blending of the other curves, and you've got a really nice mathematical growth pattern of logic and math and algorithms. That said, pretty easy. Bring them all together. You can pipe them, which is kind of boring. You see the preview of the pipe. Pipe's fast. You can do a mesh pipe if you want. That's even quicker, but it's only under 1,000 milliseconds. So leave that one off. I'll take that disabled, and I like to put it in a variable pipe. And as soon as you put it in a variable pipe, you get this awesomeness. And you can do so many different graphs on what you want to do and keep pushing that and make your own codes and scripts. Like you can take that range just like I did here with that range. I don't have to go through a graph mapper that's defined. I can go through this range and define whatever I want in here. I can go in here and be totally mathematically minded, use the expression nodes, use this, use Python, use C. You can go in here and just type in the expression, type in what you want. You can add all of your incredible plus, minus, subtraction, amplitudes, whatever you want in there. Whatever you do to a range is the same thing you can do here. You don't have to trust these graphs to have a visualization of what you do. And I'm not going to play around with it because I'm going to leave that up to you. But I love this script. It's juicy, juicy. This is totally what I'm into when it comes to Grasshopper. Let's throw that one back into the rendering that it was. This one back into artistic. And I'll leave this script. Actually, let's grab it all and just put it into a group and make that nice juicy color blue because I love blue. And we'll keep going with these other nodes because I'm going to jump into evaluate curve, perpendicular frames, and torsion. I think torsion is going to do some pretty exciting things just like this did. And that said, I'm going to make everything visible that was there. I like the blue. I throw on a little turntable for fun. Ooh, if I could spell it right. Turntable, I use it so often. I'm not really into rendering, so Actually, this is the one I want. Oops. And I just jumped it out of the picture. Let's do that one. Let's do a little turntable. And that should actually turn that. Oh, you can see it's gone a little nuts. And I've selected it, which is not what I want to do. Always a hassle with turntable. Hard to do anything once you're locked into it. Yeah, a little bit of confusion. Yeah, if you're going to zoom out, you're going to get all those jolt third derivatives, and then it just goes nuts. So not something you want to do. And I just lost my image pretty much completely. So let's go back into artistic, center it, and we know it's tucked in there somewhere, and there it is. Oh my gosh, what a juicy, juicy form. There it is. And that's what I meant to throw in the turntable to show you what was going on. I like it. A little subtlety I do at the ends of the pipes to make them look nice. I always put them into capping them, not flat, but into round. That always makes for something interesting. And I don't know if I'll ever make this, but I certainly know I made it digitally. And I kind of get tired after 30 years of manufacturing artworks to just turn it all into digital. Why not just design digitally and leave it and reside it there? Take it into AR and VR if you want to. Got some other scripts here underneath it. Nice little script. Thanks for watching. Hope you enjoyed it. We'll get into torsion and these pretty common evaluate curve and perp frames, but that's the one I want to experiment with our next script. I'm very playful. Just create these as they go and have fun with it. Save my file. We're cool.